Hello and welcome to this accompanying tutorial of Vectric Aspire 9 that goes with the last CNC routing of that beautiful little pony in a log. So we start with leveling that piece of material or the log. It's very uneven surface, so we need to make it flat. So we're going to carry out a surfacing operation. So we need to set it up. This is okay. So our measurements are 180 millimeters by 300 millimeters. Now it's the relief that we're going to be putting into this is 15 millimeters in depth, so we need to just cover that. So if we put 20 millimeters of depth, that means, you know, we've got we know that it's going to be more than sufficient, and we also know that the log is about 100 millimeters in thickness or more, but for this case 20 millimeters in this box is fine. So this box is just indicating whether we want to start at we want the zero at the material surface or the machine bed. I always operate at the material surface. I find it the safest way because the material is such an irregular shape. It's much easier for us to work from the center of the material. I always leave this as standard. It's fine. It always, you know, I don't have any problem at all. And if you put this up to a higher level, it can actually slow your computer down. The material appearance, in this case, I'm going to go mahogany. We're going to, incidentally, this is a wizard or a conversational. It is the way that these programs communicate with you. So we're going to OK that. OK, so the first thing now we need to do is draw a boundary square. So we're just going to, and you'll notice that I have, if you notice, the cursor will change to a circle with a cross. This is because I have snap turned on within the program. So we want to cover the whole of this material, and that's okay. Apply, close, and we're going to select that square that we've just drawn and jump straight through to select a machining process. Now I always select a pocket because it just works best for me. This is okay, 5 millimeter. And there it is there. That's our 1 inch or 25.4 millimeter end mill. We're going to call it an end mill, and that's fine. So we'll select that. Now let's edit that. 5 millimeter depth, that's fine. Step over of 10 millimeter, that's fine. Spindle speed 18,000 RPM, that's okay too. Feed rate 50 mil per second. This is okay. Now what I normally do in Mark 3, and you'll see in the actual video of me machining this, that I start up Mark 3 at about 20%. So it's going to be 20% of this figure that the router will actually run at. Then when I see everything is cutting okay, then I'll ramp it right up to 100%. So these settings of speed and feeds are fine for doing this this cut. So now we come to the strategy or how we want to machine this. So we have several choices. We can either do raster, which it will go back and forth in the X. In this case, I like to do an offset, and I have a choice of conventional or climb. So in this situation, I'm going to go with conventional milling. Ramp 5mm. In other words, tool's going to come along and start ramping in 5mm above the material surface. Material safe is 5mm, which is fine, and pocket 1, that's fine. And we're going to calculate. It's done that quick. And let's have a look, see what it's going to do. Here we are, start in the middle, work its way out. And I'm fine with that. Close. Now, the next thing to do is to save that. Now, a lot of people ask me, oh, what do you save in? What type of G code? Well, there's many different G codes that Aspire will actually write it in. Now, I find that nearly all machines understand and will react quite well with G-code millimeter tap or G-code inch tap. I work in millimeters, so in this case that's what we're going to use. Now, this computer is not connected to my machine, but you can actually output direct to your machine if your computer is connected to your machine. So and that's it for that. So now we will go to setting up our 3D image in Material. Okay, so here we are back in Aspire. Now, exactly the same setup and size, and we can go straight into our clip art. And with Aspire, also you get over 600 3D clip arts. So we just scroll down through some of them now till we get to our pony, which is there already in a dish. So you just drag and drop to the center, like so, and just hover over one of the corners and right click and just pull it out. So if you pull it out too far, you can see that it's blocking out the line there. So just until it's not quite over that line. Just there. Okay, so now we want to modify. We want to put in here now the depth that we require. So now you go into modeling, and this symbol here, this will allow you to alter the Z scale. And in our case, it's nearly there. I want 15, or as close as to 15 as I can get. Let's just right there. That'll do us actually. And if you go into 3D, there's our horse. And you can actually roll it over and make sure that it is, it's not gone distorted and out of shape. And in fact, that's beautiful. If I'd have gone, say, 20 millimeters, it would have gone distorted and out of shape and not look quite right. but in our case that looks pretty perfect. So now we can jump straight to 3D carving it. So we're going to go straight to a 3D carving, straight to a 3D finishing toolpath. Now I do notice in the comments that people are saying to me, oh, why didn't you use a bigger tool to remove some of the material? Well, what I have found is if you use a tapered 2mm ball mill like I use, you don't need a roughing tool path. You don't need to put an end mill in there or a larger ball mill. It's just really a waste of time. I use carbide, solid carbide, tapered 2mm ball mill, and it'll do up to a 25 or 30mm depth of cut in any material you want to put it in, and it lasts a very, very long time. It would probably carve quite possibly, I suppose, 400 or 500 of these single designs if it was in mass production. It probably wouldn't have any problem doing that at all. Okay, so what I'm going to do, actually I'm going to go back. Let's go back here a second. Let's backtrack a little bit. I'll show you a little trick that you can do as well. Because I don't want to waste time. I don't want to cut any of this area, the flattened area here. I just want to cut it on the inside of this dish. So what we're going to do, we're going to get a circle. Well, first of all, let's go into 2D. And we're going to come to the middle here. And we're going to fetch this out to about there. That'll be fine. And we're going to apply that and close it. And we're going to select that. Okay, so remember we've selected that vector. Go into 3D because you can't see it now. Okay, and see, I regularly use a 2mm tapered ball mill, and it's already selected there. Aspire will actually learn the way in which you machine, and it preempts what you want to do. So in this case, (2mm) diameter, 6mm, tip radius of 1mm. Yep, that's fine. I'm actually going to up this to 22,000 RPM. I want it spinning really quick. Step over. Now this is why I don't get any furring or fuzziness or very, very little finishing, because the step over I use with this particular tool is 0.15 of a millimeter. There again, feed rate 50 millimeters a second, and again I will start this up normally between 20 and 30% of this figure, and then when I see things going okay, I'll bring it up to 100%, and sometimes I'll even take it up to 150% of that, because I know that my machine will quite happily machine at 100 millimeters a second, which is 4 inches a second. Tool 2, and I'm going to OK that. Now, boundary, selected vector. That's what we want, because if you remember a few minutes ago when we drew that circle and we selected it and then carried through to the 3D machining part of it, I left it selected. So that's why I'm choosing selected vector, and anything inside of that vector it will now machine. And I want a raster. In other words, it's going to start off and just go back and forth, back and forth, back and forth until it machines the whole item. Safe Z 5mm fine, that's okay. Home position X0 Y0 plus Z 5mm, that's just reassuring me that we're starting in the middle. 3D finishing cut, let's calculate. Big sea of blue now. There it is. A lot of cuts, a lot of cuts. So let's preview that. And that is exactly what we're going to end up with. As you've seen if you've watched the video preceding this. That's exactly what we end up with. So we're going to close this and save this again. Save toolpath. 3D finishing 1. G-code millimeter tap and save. So there you are. I hope you've enjoyed the tutorial today, and please press like and subscribe, and please leave some comments and questions if you have them down below this video. And well, bye for now.